Their size, shape, and function run the gamut, ranging from beakers and test tubes to petri dishes and vials. Mixing, measuring, storing, or sampling is all in a day's work for a piece of laboratory glassware, built to withstand even the most potent of chemical concoctions. Many scientific breakthroughs are born inside laboratory glassware, the containers scientists use to hold samples for chemical experiments. The glassware starts off as thin glass tubing, stacked by size, weight, length, and diameter. Workers select the correct size for the culture tubes they're about to make and place them in a magazine. As it spins, it drops a tube into each slot on a cutting bed. Then comes the flame. When the heated tubing contacts the wet steel blade, the thermal shock results in a clean separation of the glass. The tubes get a second thermal shock treatment which cuts them to length. Then it's on to the glazing bed. A glazing burner shoots out 1200-degree flames. The heat melts each tube at one end, forming a lip called the glass bead. Just 2 seconds of heat splits the tubes in half and forces the glass bottom of each tube to close in on itself. The finishing fire smooths out the closure. Then, a small amount of air is shot into the open end of the tube to form its round bottom. Now the tubes head into an annealing oven side by side. They bake for about 15 minutes at 1200 degrees. This strengthens the glass so it'll better resist cracking. The heat also sterilizes the tubes. Once the tubes cool, workers collect and pack them. Here, they're making pipettes, long tubes that labs use to transfer fluids. A flame heats the glass to form an indentation which determines the flow rate through the pipette. A wider flame then heats the glass, making it soft and malleable. Large rollers tug at the sides, drawing the soft glass to form the pipette's tip. Now, for the other end of the pipette. Thermal shock is used to cut it to length, and again, a glazing burner forms a glass bead along the rim. A cutting wheel slices through the tip end, creating 2 tubes of identical length. This production line makes vials. These gizmos, called top turrets, feed large glass tubes into a machine. First, a punch-out burner heats the end of the tube to create an opening. Then, a steel pin widens the hole on the upper part of the vial. A forming die squeezes the heated glass to sculpt the shoulder, while a steel plug rises from the bottom to open the vial even wider. Then, a second forming die shapes the neck. Next, a parting burner splits the vial into 2. A bottom turret plucks the newly created half and draws out the soft glass to lengthen it. Fingers inside the turret prevent the glass from breaking. All that's left now is shaping the bottom of the vial. A burner forms a concave base in less than a second. The vials now slide down to what's called an afterformer machine. Here, suction cups lift and place each vial into metal grooves on a printer bed. It's a basic silk screening process, with a squeegee pushing paint through the screen's holes onto the vial. Grippers place the vials on a rack headed for the oven, where they'll bake for about 20 minutes. Finally, a robotic arm whisks the finished vials to packaging. From there, it's off to a blood bank, a hospital, or chemistry class.